So today I'm going to be talking about oxyacetylene welding and the chemistry behind it. So for those of you who don't know, oxyacetylene is a type of welding we use. We can either fuse metal, lay welds down on top of metal, or actually cut a piece of metal in half. It's equal parts acetylene and oxygen gas. To think of acetylene, think of high-powered propane, except it's a little bit different. Propane produces a lot of heat, which is why we use propane in stoves and fireplaces and things like that. It disperses heat very well. Acetylene burns hotter, which means that it's a very focused stream of heat, allowing for the cutting and welding capabilities. But standing around a flame, you're not going to get, hot. You're going to get a little bit warmer, but you're not going to, be burning up. The flame is actually operating at about 3,000 degrees Celsius, which is a lot. So this is a standard welding torch. Here's the torch body. We actually attach tanks of gas and oxygen to this so that they mix. So for a close-up of the torch body itself, oxygen gas comes down the middle, acetylene comes around it, and they thoroughly mix in this chamber, like cake batter. That means, you have to mix it so you don't get pockets of flour. And we need that complete reaction for the next stage to take place. Now, technically, we do a 1-to-1 ratio with the tanks. For one volume of acetylene, we need 1 volume of oxygen. But we actually need more oxygen than that. So we pull the other 1.5 volumes of oxygen from the air, and we use that to complete our reaction. So this actually has 2 reactions taking place. First is in the inner luminous core. It looks like a bright little stick coming out of it. It almost hurts to look at, and that's the most dangerous part of the flame to stare at. The rest comes out of a big flame coming off of it, and that is a byproduct of the second chemical reaction, which is actually where we bring in atmospheric oxygen. So the first chemical reaction is between acetylene, CH2H2, and oxygen, the oxygen we are funneling in. And that forms carbon monoxide and hydrogen gas, both extremely hazardous to somebody's health. But in the second stage, we actually get rid of it all. So oxygen from the atmosphere combines with the already made carbon monoxide and hydrogen, and we form carbon dioxide, which normally is vented off in a shop, and water vapor, which also is not hazardous. And so this chemistry is what makes oxyacetylene so strong and so powerful and so amazing. And that is one of the things I love about welding with oxyacetylene.